Right now, as you watch this, 15 volcanoes are erupting on planet Earth. You had no idea. Nobody sent you an alert. The news didn't break, because 15 is normal. 50 to 60 volcanoes erupt every single year, and life goes on. But here's the question that should keep you up at night. What happens when all of them go at once? Not just the 15, not just the 50, all 1,350 active volcanoes on Earth, simultaneously. And here's the part nobody talks about. They're not even counting the million-plus volcanoes sitting underwater right now, quietly waiting. This is what happens, minute by minute, day by day, until there's almost nothing left. The moment every volcano fires at once, the ground shakes everywhere. Not just near a volcano, everywhere. The shock waves, called infrasound, travel faster than the eruptions themselves. They ring the earth like a bell. This actually happened when Krakatoa exploded in 1883. Its pressure wave circled the globe 7 times. Every barometer in the world detected it. Now, imagine that from 1,350 points at once. Within the first hour, anyone living near a volcano faces something no shelter can protect against. Pyroclastic flows, incandescent avalanches of superheated gas and rock, moving at 700 kilometers per hour. You cannot outrun them. You cannot hide from them. They burn everything. Coastal volcanoes, places like Krakatoa, like Tonga, don't just erupt upward. They erupt outward into the ocean, displacing billions of tons of water. Hundreds of simultaneous tsunamis, racing across every ocean basin at once. But here's the thing. The first hour is not what kills most people. What happens in the next few weeks is far, far worse. Within hours, volcanic ash begins blanketing the skies. And here's something most people don't know about volcanic ash. Unlike snow, it doesn't melt. It doesn't dissolve. It's abrasive like ground glass. And when it gets wet, it conducts electricity. Every major power grid sits exposed under open sky. As wet ash settles on electrical insulators, it creates a path for current to arc straight to ground. Power engineers call it insulator flashover. Grid failure, city by city, continent by continent. No power means no fuel pumps. No fuel pumps means no trucks. No trucks means grocery stores run empty in 72 hours. Most cities hold exactly 3 days of food. Aviation shuts down within hours. Volcanic ash doesn't just dirty a jet engine. It melts inside the turbine at over 1,000 degrees, then resolidifies as glass ceramic coating the blades. Engines stop. There is no recovering from that mid-flight. Global supply chains, food, medicine, fuel gone. But the ash is only the beginning. Rising above the ash, something far more dangerous is climbing into the stratosphere. Sulfur dioxide, SO2, the real killer. Every volcanic eruption releases sulfur dioxide. One eruption, Mount Pinatubo in 1991, injected 20 teragrams of the stuff and cooled the entire planet by half a degree for 2 full years. We're not talking about one Pinatubo. We're talking about the combined output of 1,350 volcanoes releasing an estimated 6,000 to 60,000 teragrams of sulfur dioxide. Once in the stratosphere, SO2 converts into sulfate aerosols, billions of microscopic droplets of sulfuric acid that act like tiny mirrors, reflecting sunlight back into space. They don't fall out like ash. They sit up there for 1 to 3 years. And while they're up there, something else is happening. Something most people never talk about. Volcanoes also release hydrogen chloride and hydrogen bromide, halogen gases. When these reach the stratosphere, they destroy ozone through a catalytic chain reaction. One single eruption, the Hungatonga volcano in 2022, caused 7 to 14% ozone loss across the southern hemisphere. One volcano. Now multiply that globally. Decades of recovery from the Montreal Protocol reversed in days. By week 2, the world looks different. The global average temperature starts dropping. 1 degree in the first month, 3 degrees by month 3. In mid-latitudes, summer temperatures may not climb above freezing. For comparison, the ice ages, which buried continents under kilometers of ice, were triggered by just 5 degrees of cooling. Over thousands of years, we're talking about 10 to 30 degrees dropping over months. History has already shown us what even a fraction of this looks like. In 536 AD, a volcanic eruption somewhere in Iceland or North America, we still don't know exactly where, created a veil of aerosols that blocked the sun for 18 months. The Byzantine historian Procopius wrote that the sun gave off light without brightness, like the moon. Temperature dropped just 1.5 to 2.5 degrees. That was enough to trigger the coldest decade in 2,300 years. Crops failed across Europe, the Middle East, China. Snow fell in summer in what is now New England. Famine spread, and then in 541 AD, 5 years later, with populations already weakened, the bubonic plague arrived. One volcano, one cold snap, and historians now call it the beginning of the worst century in human history. Harvard historian Michael McCormick says 536 AD was, quote, the beginning of one of the worst periods to be alive, if not the worst year. And that was just one volcano. Then there's Tambora, 1815, the largest eruption in recorded human history. It cooled the Earth by less than 1 degree. Less than 1. But that was enough to cause the year without a summer in 1816. Crops failed across Europe and North America. Bread riots. Famine. 90,000 dead from the eruption and its aftermath. And here's the twist. The eruption may have changed the outcome of the Battle of Waterloo. Volcanic aerosols in the atmosphere are believed to have caused the unusually heavy rain and mud that slowed Napoleon's artillery, contributing to his defeat. One volcano possibly altered European history. By month 6, something quietly catastrophic is happening in the oceans. Phytoplankton. You probably never thought much about them, but they produce 50% of every breath of oxygen on Earth, and they run entirely on sunlight. As global dimming deepens, phytoplankton populations collapse. And when the bottom of the marine food chain disappears, everything above it collapses too. Fish, whales, marine mammals, gone. At the surface, ocean chemistry is changing. The oceans absorb CO2 and SO2 from the air. This makes the water more acidic. And in acidic water, anything with a shell, coral, oysters, clams, snails, the tiny creatures at the base of everything, can no longer build their structures. On land, it's no better. Wheat needs temperatures above 5 degrees Celsius to grow. A 10-degree drop eliminates wheat production across the entire northern hemisphere. Rice holds out a little longer in the tropics, but not for long. Scientists at the Alliance to Feed the Earth in Disasters, all fed, have studied exactly this scenario. Their term for it is an abrupt sunlight reduction scenario. Without preparation, they project global catastrophic food failure within 12 to 18 months. They have identified alternatives, bacteria grown on hydrogen gas, seaweed that doesn't need direct sunlight, protein extracted from leaves, sugar extracted from wood. These foods could theoretically sustain a population through volcanic winter. There's just one problem. Every single one of these solutions requires functioning infrastructure, power grids, factories, logistics networks. And those went offline in week 1. So, you've survived the volcanic winter. Somehow, 18 months in, the skies have been dark. It's been brutal. But one morning, you look up and the sun is actually back. Bright, clear sky. Here's the thing. The sulfate aerosols fall out of the stratosphere in 1 to 3 years. Gravity always wins eventually. The sky clears. But the ozone isn't coming back. Not for a very long time. All that HCl and HBr that the volcanoes pumped into the stratosphere spent the last 18 months destroying ozone catalytically, continuously. The ozone layer that took humanity's entire industrial age to damage and decades of the Montreal Protocol to begin healing is gone. And now that the aerosols are gone and the sky is clear, ultraviolet radiation pours through at levels the Earth's surface hasn't seen in geological time. UV at this intensity causes DNA damage in plant cells, in phytoplankton, in any animal exposed to the surface. The crops that manage to survive the cold, now they're being killed by invisible light. You survive the darkness, and now the light is killing you. And then, the final act. CO2 doesn't behave like sulfate aerosols. It doesn't fall out. It stays in the atmosphere for hundreds to thousands of years. The volcanic eruptions pumped enormous quantities of it upward. And now that the cooling layer of aerosols is gone, that CO2 begins to act as a blanket. Cold first, then hot. This is not a theory. This is exactly what happened 252 million years ago. The Siberian traps. Centuries of volcanic eruptions across Siberia released 36,000 gigatons of carbon. What followed was the Great Dying, the worst extinction event in Earth's history. 96% of marine species gone. 70% of terrestrial species gone. The mechanism, volcanic winter, then CO2 warming, then ocean acidification, then collapse. We're not descended from the dominant species of that world. We are descended from survivors, tiny, desperate survivors who made it through the worst. And that took millions of years to recover. There's one survival angle that almost nobody thinks about. The places most likely to remain functional after all this? Iceland, a nation built on top of active volcanoes. They already run on geothermal power. The volcanic activity that destroys the rest of the world is the same energy source keeping Iceland's lights on when the grid everywhere else is down. The people most likely to survive a volcanic apocalypse are the ones who live on volcanoes. 72 hours. That's how long most cities have before their food supply is exhausted after supply chain failure. Anyone in a dense urban area who doesn't have direct access to food production is, statistically, the first to go. There's a harder truth underneath all of this. Even if some survive the volcanic winter, even if some populations make it through the ozone crisis and the warming rebound, rebuilding is not guaranteed. Modern civilization runs on a network of specialists, power engineers, semiconductor manufacturers, pharmaceutical chemists. If those populations fall below critical mass, if that specialized knowledge doesn't survive, you can't just restart. The complexity of civilization requires a minimum density of people who know how it works. History is full of civilizations that collapsed and never came back. Not because the resources were gone, but because the knowledge was. 74,000 years ago, the Toba supervolcano in Sumatra exploded. Just one, a VI8, the largest eruption in the last 2 million years. Evidence suggests the human population may have bottomed out at just a few thousand individuals. Every human alive today could be descended from a handful of survivors. That was one volcano. We have 1,350. Survival rating, 0 out of 10. Would not recommend, unless you live in Iceland.